Hello everyone. Today we are going to talk about when we say rate of something, we are measuring the change in a specific factor over a period of time. In chemical reactions, we can measure the rate of chemical reaction by measuring what? By measuring the changing in concentration over a specific period of time. And changing of concentration, it can be measured either for reactants or products. Okay? So we can measure how much we are consuming a reactant or how much we are producing a product or forming a product. Okay, we can plot a graph to show the changing in that concentration and also the rate of reaction either for reactant, and we can see here that graph, it's a decreasing curve. So to use that graph to measure the rate of reaction, we have to draw a tangent at a specific time and find the slope or the gradient of that tangent. In order to draw a tangent, I will draw a straight line from x-axis until we hit, I'm sorry, this is not straight line, until we hit uh, the curve, okay, until we hit the curve uh, by this, assume it's a straight one. We have drawn a straight line. From that point, I will draw a tangent that is touching my curve, okay? I will find the slope for that tangent by finding what? The difference or the change for 2 points on y-axis you will read for or related to that tangent, and the x-axis points related to those y points. So it's mathematic wise. You are going to mathematically, as usual, how can you find or calculate any slope for any line? You will find the difference between 2 points at y-axis over or divided by 2 points of x-axis for the tangent, not the curve. This value, it will give me also, it's the tangent or it's the gradient for the curve, and we can assume it's as what? It's as the rate of the reaction at a given time. Okay, here we have decreasing, we have the maximum at 0 time, we have the maximum amount or concentration of the reactant, and it will start to decrease until we reach what? Zero concentration of the reactant. We have consumed all of the reactant. This means the slope here is 0, and also we will assume that rate is 0 because the gradient or the slope, the same word, it equals the rate of the reaction. So when the gradient is 0, it means also at this phase of time we can see that the rate of the reaction is 0 also. Okay, if we sketch a graph for a product, the graph will be the opposite for the one that for reactant. It will be an increasing curve. Okay, this is an increasing curve. To find the initial rate for the chemical reaction, we can also draw a tangent touching my curve at point 0. Okay, so I'm going to draw that blue line from 0. Then I will find the slope for that tangent. This will give me the value for initial rate. For any given time, we can measure also the rate in the same way by drawing a straight line until we hit the curve. Then you will draw the tangent, and you will find the slope for that tangent. After we have consumed or the reaction is completed, we will reach what? A constant phase. This constant phase, we can see from here that the slope is zero, and also at the same time we say that the rate of the reaction also is zero. Okay, there is no changing in the concentration of the products as we have finished my reaction. Okay, in some chemical reactions, we can produce gas. So we can use this phenomena in order to find the time taken for collecting that gas in order to calculate or measure your rate of reaction. So let's assume we have a reaction between calcium carbonate and hydrochloric acid. This reaction will give me what? It will give me CO2. So I will collect the CO2 at several times or at several intervals, and the time taken for collecting the gas, it will be as what? As a measure for your rate of reaction. So for collecting the time taken, the rate of reaction can be calculated from the time taken for a known amount of product to be formed. Okay, so here we are producing carbon dioxide, so we will measure the time taken for collecting or producing 20 centimeter cubed of that gas. Okay, and then you can calculate the rate of the reaction. Okay. A chemical reaction. When we will have a chemical reaction, in order to have a chemical reaction, we need collision to happen between molecules or reactants. Consider that chemical reaction, it's a reaction between molecule A and B to produce C and D. Okay? In order to have a chemical reaction between A and B, we must have the following. Those molecules must possess minimum amount of energy. This minimum amount of energy, it's called what? It's called activation energy. So activation energy, it's possessed by what? Reactants in order to be reacted to each other to form a products. Okay? And also we need what? The correct orientation between those reactants. We must have what? The correct orientation. What's the meaning of that? This is a chemical reaction between ethene and hydrogen bromide. Okay? In order to have a chemical reaction, we have three possibilities for collision. Okay? Possibility number one or collision number one. I'm sorry. Uh, what happened? Okay, we can see here that this molecule have collided the ethene in the position of the double bond. Is that reaction will give me the products? Let's think about it. Hydrogen is partially, it's positively charged or partially positive particle, and the double bond is what? It's a negative area. So reaction between negative and positive, it's a correct orientation. But in collision number two, we are colliding the double bond, which is a negative area, by a negative ion, and this is incorrect. And this collision or orientation will not give me products. So this orientation is not my orientation to have a products. In collision number three, also we are colliding the ethene by the hydrogen atom from the hydrogen atom here. So hydrogen with hydrogen will not react with each other. So collision number three, it's not the correct collision to have a chemical reaction. Okay? So again, in order to have a chemical reaction, we must have what? Two conditions, activation energy and correct orientation. Thank you for listening, guys, and see you in the next